Okay, I want to take a look at the clock problem from this morning. Now, whether you have done this online or if you were in class today and we worked it out on the board, I think this will still be valuable. I'm going to present my method using the graphing calculator on Desmos.com. This is a handy tool for graphing things, and if you make an account, you can get little shareable addresses to show the exact same graph to somebody else. It's nice. The problem that we have is asking how many times do the minute hand and the hour hand on an analog clock cross starting at 12 a.m. and ending at 12 p.m. So my method, since I'm a calculus teacher, is to say I'm going to look at this in terms of the graphs of functions. And using those graphs will help me understand. So first thing I'm going to do is I'm going to change the parameters here. My x-axis is going to start at minus 10. I'll keep that. And it's going to go up to 14. I do that so that I can actually see from, this should be like minus 2. There we are. I do that so I can see 0 up to 12 hours. My y-axis, similarly, let's go from minus 10 up to 360. So I'm going to be thinking of this. The x-axis is time. The y-axis is degrees around the clock. My first function is going to be telling me the angle of the hour hand. So I'll be using completely vertical as 0 degrees, and I'll be counting my degrees clockwise, because I'm talking about a clock. So from 0 to 12 hours, every hour moves me 1/12 of the way around the circle, so that'll be 30 degrees. So y equals 30x. I see that I start down here at 0 degrees at midnight, and then I'm back up to 360 degrees at noon. That looks good. My second graph, my second function, is going to be what is the position of the minute hand. So the minute hand goes all the way around once an hour. So that's going to be 12 times as fast as the hour hand. So I can start off and say y equals 12 times 30 times x. And now I've got a problem here that my function goes outside the bounds, right? So if this was on a clock, I'd be wrapping around. And I can fix that here. So let me go ahead and insert some parentheses here. That's the function I want. And what I want to do, there we are, is I need to subtract off every multiple of 360. So what I'm going to do is I'm going to take the floor function of, what's going on? Excuse me. I'm going to take the floor function of that, and I need to divide this term by 360. The floor function tells me the next integer below the quantity I'm looking at. I'll multiply on 360 in the beginning because I'm subtracting off multiples of 360. So now the blue line is showing me what the minute hand is doing. It goes up to 360, wraps back around. And now at this point, all I have to do is count the number of crossings. And I can see I've got a crossing at midnight. I've got a crossing a little bit after 1. I've got a crossing a little bit after 2, a little bit after 3, and so on. So altogether, across this time period, I've got, count them up, 12 crossings. So that would be one of the ways that I think about this problem. This isn't the only way to think about this problem. There's lots of different ways to get the right answer. This is just the way that makes sense to me in the context of this course. And there's actually plenty of other ways I like to think about that too. Now, for the rest of tonight's lectures, I have some other videos that I want you to be watching. If you want to re-watch, if you want to rewind and watch my clock bit again, that's totally fine. That's one of the benefits to this format. Please also look at another lecture that I've copied from a previous class. I'm not expecting you to memorize that content, but I want to get your feedback on the quality of that video. So please watch that video and answer a little survey about how you think I did. This will help me greatly to make the videos work for this class too. And then the final video for tonight is just a fun song on YouTube. It is about mathematics. So I hope you enjoy that too. I look forward to seeing you whenever I see you, whether that is on Tuesday or on Thursday or maybe even later than that. And have a pleasant evening.